Hi everyone, today we're going to be solving Edexcel IGCSE paper 1C. In today's video, we'll be solving June 2018. We'll be solving the entire question paper in this video. Guys, let me know your feedback in the comments. If I have made any mistakes or if you want any question paper in particular, specifically the earlier question paper, if you want them to be solved, please let me know in the comments. Alright, so guys, let's get started. Chromatography can be used to separate the substances in a mixture. The diagram shows the apparatus used to separate the different dyes in a food coloring. So we have the food coloring and we have this particular start line. So we know that the start line will be drawn in pencil. So this pencil line will be the baseline, and then we have this particular label which will be the chromatography paper. Then we have solvent front. This will be the solvent front. This is the maximum distance the solvent has traveled within that experiment. And here we can see another labeling. So definitely that will be the labeling for the solvent. The box lists some terms used in chromatography. We can see the baseline, chromatography paper, solvent, and solvent front. They wanted us to do this particular labeling with this particular box. So we have already done it. So let's just move to the next question. The diagram 2 shows a chromatogram produced using 4 different food colorings, P, Q, R, S. All right. So we can see that P and Q has a common color. All right. We can see QRS has a common pigment. So that's about it. All right. Which food coloring contains only one dye? One dye will result in one spot. So we can see R has one spot. Which food coloring have one dye in common? So from the PQRS, all right, so they give us option PQR, PQRS. We know that QRS has one dye in common. We can see that here. So QRS has one dye in common. Then explain which food coloring contains the largest number of dyes. We can see P has the largest number of dyes because there are 4 spots present. So we will write down the explanation in this way. So the answer will be P has the largest number of dyes. That's the first point. And then the second point we're going to write because there are 4 spots in the chromatogram means there are 4 pigments. The diagram shows the apparatus used to prepare carbon dioxide in the laboratory. We can see dilute hydrochloric acid in a thistle funnel, and then we have calcium carbonate in a conical flask. We have the delivery tube, lead, and gas jar. What is the name of the piece of apparatus containing the dilute hydrochloric acid? So the apparatus here that contains the dilute hydrochloric acid, it has a tap in it. Since it has a tap in it, so it will be a tap funnel. Complete the chemical equation for this reaction. We can see calcium carbonate is going to react with hydrochloric acid to produce calcium chloride. To balance this chemical equation, we'll notice that there are 2 chlorines on the right hand side. We need to balance that, so we're going to do to balance the number of chlorines. Then we will notice that there are 2 hydrogens which we will need to balance with a H2O. Alright, so that balances up. There are 3 oxygens in here, 2 oxygen here and 1 oxygen over here. So that is balanced out, and the calcium, 1 calcium, 1 calcium, 1 carbon and 1 carbon, it's also balanced. So this equation needs to be balanced in this way. Which of these is a true statement about carbon dioxide? We know that carbon dioxide turns lime water milk. So it turns lime water milky. This will be the correct statement. Now it turns litmus blue. Red litmus turns blue in a presence of alkaline substance. Carbon dioxide is acidic. It relights a glowing spill. Okay, let's just consider that the splint anyways. However, we know that CO2 will extinguish any fire. Okay, it burns with a squeaky pop. Only hydrogen burns with a squeaky pop. So that is also a wrong answer. This will be the correct answer, guys. The diagram shows how carbon dioxide is collected by downward delivery in air. Give a reason why carbon dioxide can be collected by downward delivery in air. The main reason for this is CO2 is dense. CO2 is heavy compared to the normal air that is surrounding us. Since CO2 is heavy, so it is more dense than air, so it sinks at the bottom, and then the air within that particular tube gets displaced. Our answer will be very simple. It is more dense than air. Give another method of collecting carbon dioxide. Now, carbon dioxide can be collected easily using a gas syringe. So a gas syringe, the carbon dioxide, as it enters the gas syringe, it will push the plunger behind. So we can use a gas syringe. Another method we can collect a gas specifically some of the gases, those that are less soluble in water, will be collection over water. When carbon dioxide dissolves in water, a weakly acidic solution forms. Suggest a value of the pH for this solution. So you can see CO2 is acidic gas, makes a weak acid. A weak acid will have a value of like 5, 6, because it's going to be close to 7. So we can say either 5, we can say either 6. All right, just remember that either write 5 or 6. Carbon dioxide also forms when copper 2 carbonate is decomposed by heating. The equation for the reaction is copper carbonate heated, it turns into copper oxide and carbon dioxide. Okay, so they asked us to state the change in color of the solid when copper carbonate decomposes. So you have to memorize this particular information, that copper 2 carbonate is green in color. And what happens when it gets decomposed? It goes to black in color. So green to black. Copper oxide is black and copper carbonate is green. Suggest 2 properties of carbon dioxide that make it suitable for use in fire extinguisher. So the first point that you can go for is, you know that CO2 will extinguish any fire. All right, so we will say CO2 or carbon dioxide does not support any combustion. Normal burning, it doesn't support it. I mean, only in the case of if there is a lithium fire or if there is a magnesium fire, these are reactive metals, as you know. If a fire is related to these metals, then carbon dioxide will not be able to help, because these particular elements has the ability to take away oxygen from carbon dioxide. So CO2 is not an extinguisher for them. However, in a normal fire, all right, in a fire where there is something burning, organic material specifically, like wood, or think of a cloth, or think of a paper, or anything that is usually organic, if they are burning, then definitely CO2 is a good extinguisher. And the next thing that supports the idea is that CO2 is denser than air. So if you were to pump CO2 in any place, it will sink at the bottom, as if it will also stop any oxygen, any air from the surrounding from reaching that particular fire, from reigniting that particular fire. So these 2 properties makes it very good in the fire extinguisher. A teacher investigates the reaction between sodium and water. The teacher fills the trough with water. She adds few drops of litmus solution to the water and then adds a piece of sodium. So we can see the sodium. Now the sodium will react with the water definitely. The sodium floats on the water. It reacts with the water, produces bubbles of hydrogen gas. State 2 other observations that are made during this reaction. So we already know that it floats in water, and we already know that it is producing bubbles. So we can't write them. The other 2 points that we can write is sodium slowly disappears, because as the sodium reacts, it will disappear. And then the other points that we can write also includes the sodium will jump around or move around in the water. It will melt into a ball, and since there is litmus in the solution will turn blue because sodium hydroxide will be produced. Balance the equation for the reaction between sodium and water. Include the state symbol. Sodium reacting with water produces sodium hydroxide and hydrogen. So in the case for sodium is a metal, so it's going to be solid. H2O is a liquid. Sodium hydroxide is aqueous, and hydrogen is a gas. So state symbols are already done. Now we need to balance the equation. We will notice that on the right hand side we have 3 hydrogens, 1 plus 2. So we will put a 2 in front of the sodium hydroxide to make it an even 4 hydrogen. We'll put a 2 in front of the water to make it an even 4 hydrogen. Now we will find ourselves in a situation where we have 2 sodium and we have 2 oxygens. 2 oxygen is already balanced, so let's put a 2 in front of the sodium to balance the sodium. So the equation is balanced with state symbol. Lithium and potassium react in a similar way to sodium when added to water. State why they have similar reactions in terms of electronic configuration. We know that they both contain 1 electron in their outermost shell, and also the outermost shell's electron decides the reactivity of a particular element. Since they have the same number of outermost shell electron, they will have similar reactivity. Place the elements lithium, potassium, and sodium in order of reactivity. So we know that the most reactivity is going to be definitely the one who is lower in the group. So definitely potassium, and the next, lesser than that will be sodium, and then it will be lithium. So as we go up the group 1, the reactivity decreases. Use the periodic table on page 2 to help answer this question. Which word correctly describes substances found in the periodic table? Well, we find elements in periodic table. The substances in the periodic table are arranged in order of atomic number or proton number. The table lists properties of some of the gases in group 0 of the periodic table. For example, helium, symbol He, boiling point 4 Kelvin, reaction with metal, no reaction. Complete the table by giving the symbol for neon, estimate for the boiling point of argon, and the reaction of xenon with metals. So with neon, the symbol will be Ne. I have derived it from the periodic table. You can do it too. And with argon, the boiling point in Kelvin, I'll just guess it, right? In comparison with the other ones, I can see that the next one has 121, and after that the element has a increase in 40 Kelvin in boiling point. So the previous one must have a decrease in boiling point of 40 Kelvin. I will assume that, and that thereby I will 121 minus 40 or 45. Let's say 121 minus 45 in general, all right, will give me 75 or 80. So I will just go with 80. This is how you can do it, because they say suggest or estimate. They have a huge range where they will accept the answer. Then xenon, Xe, boiling point 165, and we know that xenon is a group 0 in the periodic table. Is a noble gas, and thereby it will have no reaction with a metal. The photograph shows an electric light bulb, tungsten metal filament, and argon-filled bulb. The tungsten filament becomes very hot when the light bulb is switched on. Suggest why argon is more suitable gas than air to use in the light bulb. So, as we have already talked about that, noble gases do not react with metals. So, argon, we will say argon does not react with tungsten because argon has a full outer shell and it does not easily gain or lose electron. If the bulb was filled with air, then the filament will easily react with, the tungsten would easily react with oxygen in the air. Guys, the last statement written in black, you may choose to write it or may not choose to write it, but you will still get your 2 marks, inshallah. A student tries to make a pure dry sample of hydrated cobalt to chloride crystals. He uses dilute hydrochloric acid, solid cobalt to oxide. Step 1. Pour about 50 cm³ of dilute hydrochloric acid into a beaker. Step 2. Warm the acid using Bunsen burner. Step 3. Add a small amount of cobalt to oxide and stir the mixture with a glass rod. Step 4. Add further small amounts of cobalt oxide until it stops reacting. Step 5. Filter the final mixture and collect the filtrate in an evaporating basin. Step 6. Leave the filtrate until all of the water has evaporated. His sample of cobalt oxide contains a small amount of solid impurity that dissolves in water but does not react with the acid. State why it is not necessary to have a precise measurement of the volume of hydrochloric acid in step 1. The main reason we do not need to worry about the volume of hydrochloric acid is because at the end of the experiment we use excess cobalt oxide so that all the acids are used up. State why the acid is warmed in step 2. Increasing the temperature will increase the rate of reaction. Suggest why a glass rod rather than a metal spatula is used to stir the mixture in step 3. If a metal spatula is used, there is a chance that the metal spatula will react with the acid solution. However, glass rod does not react with the acid solution. State how the student will know when cobalt oxide stops reacting in step 4. The student will notice that the solid stops disappearing. That means the solid is left over, it doesn't react anymore. State why the method used in step 6 will not produce a pure sample of hydrated cobalt chloride crystals. The soluble impurity will also be present with the cobalt chloride crystals. State why the method used in step 6 will not produce a pure sample of hydrated cobalt chloride crystals. So the method 6 says leave the filtrate until all of the water has evaporated. So this has a problem, is that all the impurities will also be evaporated and left behind with the crystals. That will be a problem. So our answer should be the soluble impurity will also be present with the cobalt chloride crystals that will be produced. Describe how the student could produce a pure dry sample of the crystals from the filtrate in step 5. So we will give our description in a way how the student can do it so that the student can repeat it. First of all, the student can, boil the filtrate in an evaporating basin. Once the student boils the filtrate, water will evaporate and it will reach the crystallization point. Once the crystallization point is reached, it can be determined by using a glass rod. Then the student can leave the solution, the concentrated solution, in a cool place, alright, to crystallize. Once the crystals are formed, the student can filter the crystals, get the crystals. However, at that point, the student needs to wash the crystals with cold distilled water. Why washing the crystal with cold distilled water? So that the impurities that are on the surface of the crystals can be removed. Guys, generally, crystals are pure substances. Okay, so the crystals are pure, but there will be impurities on the surface which needs to be washed off with distilled water. Then the crystals will be dried on a piece of filter paper by placing it in a warm oven at a moderate temperature, maybe like 30, 40, maybe 40, 50 degrees Celsius is enough to dry it. The table shows the formula and the color of 3 different types of cobalt 2 chloride. When water is added very slowly to the solid COCl2, the color of COCl2 changes from blue to pink and blue to purple and then to pink. Write a chemical equation for the change from purple solid to pink solid. So purple has this particular COCl2.2H2O. Now we must have, from 2H2, we must have 6H2O. So we will add water, but we will add precisely 4 water. Then we will get COCl2.6H2O. Which of these words describe the change taking place when the pink solid is heated to form the blue solid? Pink solid heated to form the blue solid. The pink solid is COCl2.6H2O. Forming blue solid is removal of the water. So removal of water by evaporating in this process will be dehydration. We are removing water and removal of water is dehydration. Tests are done on a sample of solid X. Solid X contain ammonium ions and one other cation and anion. The table lists the tests that are done on the solid X. First of all, we added dilute sodium hydroxide and we warmed. Gas given off, gas turned damp litmus paper red to blue. So this gas that is given off must be ammonia. Then we did a flame test on it and we got a lilac flame. Lilac flame is an indication for potassium ions. So there must be potassium ions present as well. Then a sample of the solid X is dissolved in deionized water. The solution is divided into 3 test tubes and the following tests are done. So A, to the first test tube and add dilute hydrochloric acid. No observable change. So there must be no carbonates present. You can say no carbonates. Usually when we add acid, our main goal is to test for carbonates. To the second test tube, add dilute nitric acid and a few drops of silver nitrate. Nitric acid and few drops of silver nitrate are tested for halide. So no halide because no observable change. So no halides. To the third test tube, add dilute hydrochloric acid and few drops of barium chloride. Now, hydrochloric acid followed by barium chloride is a test for sulfate, and we can see white precipitate, that means sulfate present. Identify the gas given off in test 1, ammonia. Give the formula of the other cation present in solid X, potassium ion. State the test 3A and 3B tells you about the solid. So 3A tells us no carbonate ion present. 3B will tell us that there is no halide present. And finally, the identification of anion in solid X is sulfate, or we can write SO4 2-. Antimony, Sb, is an element in group 5 of the periodic table. The mineral stibnite contains antimony sulfide, Sb2S3. Antimony can be obtained from stibnite in a 2-stage process. Stage 1, stibnite is roasted in air plus oxygen, Sb2O4, and 3SO2 is produced. The oxide produced is heated with carbon to form antimony and carbon dioxide. State why the sulfur in stage 1 is said to be oxidized. We can see that the sulfur in stage 1 gains oxygen and turns into sulfur dioxide. Gain of oxygen is oxidation. Complete the equation for the reaction in stage 2, Sb2O4 plus C producing Sb and CO2. Since there are 4 oxygen and each carbon has 2 oxygen, so we will require 2 CO2 and we will require 2 carbon. Since there are 2 Sb in every Sb2O4, so it will produce 2 Sb. Bismuth is another element in group 5 of the periodic table. Bismuth forms an oxide Bi2O3, which has a giant ionic structure. Give the formula of the bismuth ion in bismuth oxide. We know that the valency gets exchanged, so the 3 is for the bismuth, so we will say Bi3+. Explain why bismuth oxide has high melting point. So you see there are Bi3+ ion and O2- ion present. So there is a strong electrostatic force of attraction between the oppositely charged ions, and thereby a large amount of heat energy is required to overcome these attractive forces. Bismuth oxide reacts with dilute hydrochloric acid to form bismuth chloride. Write a chemical equation for this reaction. So bismuth oxide has the chemical formula of Bi2O3. It will react with hydrochloric acid, which is HCl, to produce BiCl3. So that will be bismuth chloride. And so that's the only product. And along with that there is water. So we'll say H2O. Now to balance this chemical equation, first of all we will see that there are 2 bismuth. So we must balance it with the 2, which will give us 6 chlorine, which will balance it with 6. So 6 hydrogen will be 3 H2O. A student investigates the rate of reaction between zinc and hydrochloric acid using an excess of zinc powder. There is a zinc powder and then there is hydrochloric acid. The student measures the volume of gas in the gas syringe every minute for 10 minutes. Time in minutes from 0 to 10 minutes, and he gets the volume up to 60 cm3. The reaction we can see stops at 7th minute. Plot the student's result on the grid and then draw a curve of best fit. The result at the 2-minute is anomalous, suggests a mistake that the student could have made to produce this anomalous result. We can see that the result at the 2-minute is higher than expected. So maybe the student did not take the measurement at 2 minutes. Maybe he waited a little bit longer to take the measurement, and that's why he had the mistake. So we can write the student measured the volume of gas, later than 2 minutes. Use your graph to estimate the volume of gas that was given off at 2 minutes. Show clearly on your graph how you obtain your answer. First of all, we will talk about the volume of gas. So 2 minutes. What we are going to do is we are going to extrapolate at 2 minutes. So we will draw a straight line up until it touches the graph, and then we will draw another line that it touches the y-axis. So we can see the graph reads about 26.5 cm3. We can answer up until 3 significant figure. Alright, so 26.5 would be correct. Guys, on an answer like this, don't be scared. That's because you will get the opportunity to use your graph to give your answer. If your graph is wrong, yet this answer will be correct. Just remember to extrapolate. Explain why the last 4 readings for the volume of gas are the same. So the reaction has finished at 7 minutes. By the time it is 7 minutes, the reaction has finished. Alright, because all of the acid has been reacted. It has been used up. Zinc was in excess, so all the acid has been reacted. We can conclude that. State how the graph shows the rate of the reaction decreases during the first 7 minutes. As the reaction continues from 0 to 7 minutes, we see that the slope of the curve decreases, which indicates slower rate of reaction. Explain in terms of particle collision theory why the rate of reaction decreases during the first 7 minutes. As the reaction proceeds, fewer particles of zinc and acids are available for reaction. So there will be fewer number of successful collision between these reactant particles per second. This apparatus is used to test whether magnesium, solid magnesium chloride, and an aqueous solution of magnesium chloride conduct electricity. So we can see that there is a battery or power supply, and then we have the lamp to indicate that the electrolysis continues, and carbon rod which are used as electrodes. Substance magnesium, does it conduct electricity? Yes. Solid magnesium chloride, obviously it will not conduct electricity because there are no free ions. An aqueous solution of magnesium chloride will conduct electricity because there are free ions that can carry the charge. Explain these results with reference to the type of particles in each substances. In the metal, the magnesium, we will say that there are delocalized electrons which are able to move throughout the structure. Basically, we'll just give the metals definition, the definition for metallic bonding, which will give us the mark. And for magnesium chloride, which is solid, alright, we will say that the positive ions and the negative ions are fixed in position. They cannot move, they can only vibrate. So they cannot carry electrical charge. And for aqueous magnesium chloride, we will say positive and negative ions can flow because, they are mobile, they are in solution, they are able to flow, and thereby they are able to carry charges to the electrodes from one electrode to another electrode. Bromine is a red-brown liquid at room temperature. Liquid bromine forms a brown gas when warmed. Explain what happens to the bromine molecule when liquid bromine is warmed to form a gas. As we heat the liquid bromine, the average kinetic energy of the molecule increases. And as the kinetic energy increases, those molecules gains enough amount of energy that they can escape from the liquid. They can break the intermolecular force between the liquid molecules and escape from the liquid and move further apart, which means they can turn into gas. Bromine reacts with water to form a mixture of hydrobromic acid and hydrobromous acid HBrO. Write a chemical equation for this reaction. So we will write bromine, which is Br2, reacts with water represented by H2O to produce hydrobromic acid, which is HBr, plus hydrobromous acid, which is HBrO. Now to balance this particular reaction, we have to do nothing because there are two hydrogen in the left side, and we count there are two hydrogen on the right side. Same with the bromine. 2 and 2 on the right, and 1 oxygen on the left, 1 oxygen on the right. Hydrobromic acid reacts with magnesium carbonate to form a solution containing magnesium bromide. We can see the reaction: magnesium carbonate reacting with 2 HBr forming MgBr2, H2O and CO2. It's always a good idea to write down the reaction ratio. So 1 is 2, 2 is 2, 1 is 2, 1 is 2, 1. Crystals of hydrated magnesium bromide MgBr2.6H2O can be obtained from this solution. So the MgBr2 that we formed in the previous solution, then we can react with 6 moles of water to produce 1 mole of MgBr2.6H2O. The trick in hand is that 1 mole of MgCO3 produces 1 mole of MgBr2, which then comes into the reaction as 1 mole of MgBr2, then gets to hydrated 1 mole of MgBr2.6H2O. Guys, always try to connect the question, in terms when you have two equations, always try to connect the number of moles because it will help you later on. An excess hydrobromic acid reacted with 0.125 mole of magnesium carbonate show by calculation that the maximum theoretical mass of hydrated magnesium bromide that can be made is 36.5 grams. So when it comes to 0.125 moles of magnesium carbonate that has reacted, so we will then derive from that, because it is reacting in 1 mole to 1 mole to 1 mole to 1 mole of MgBr2.6H2O. Whatever moles for MgCO3 will be present will be the same moles for MgBr2.6H2O. So we're going to write down like this: number of mole MgCO3 equals to number of mole MgBr2.6H2O, which is equals to 0.125 moles. Then the next thing that we are going to do is we are going to find out the mass of MgBr2. So mass of MgBr2.6H2O. When we do that, then it will be 0.125 multiplied by the MR of MgBr2.6H2O, which is 292, which is equals to 36.5 grams. Now that is our final answer. So we have already shown 36.5 grams. Then we're done. In an experiment using 0.125 mole of magnesium carbonate with an excess of hydrobromic acid, the mass of hydrated magnesium magnesium bromide obtained is 26.4 gram. Suggest two reasons why the actual mass obtained is less than the maximum theoretical mass. Okay, so we have to suggest reasons. All right, guys, first of all, what we are noticing here that we are supposed to receive 36.5 and instead we have received 26.4. Now, why is it less than the theoretical mass? One of the main reason could be that the magnesium carbonate that we used was impure. Then we can say some magnesium carbonate did not react, or maybe some of the product was lost during the transfer between the pieces of apparatus. We may also say that hydrated magnesium bromide loses some water of crystallization when we try to heat it and get the crystals. Some of the product that is dissolved when the crystals are washed, then they go away and we lose our significant amount of mass when washing the crystals. All right, we may also write that the solution was not left for long enough for most of the magnesium bromide .6H2O to crystallize. So guys, there are a total of 6 points here mentioned. You can just choose any two of the points and write in the answer and it will be full marks. Malachite is a copper ore containing copper to carbonate and several other compounds that are insoluble in water. You are supplied with several pieces of malachite, these chemicals and items of apparatus. Describe how you would use the chemicals and the apparatus to obtain a sample of copper from the malachite. So chemicals provided is dilute sulfuric acid, magnesium powder. We have apparatus such as beaker, filter funnel paper, pestle and mortar. So our first step will be to crush that malachite into powder using the mortar and pestle. Once it is powdered, then we will add the malachite powder to dilute sulfuric acid in a beaker, and then we are going to use a filter funnel, all right, to filter the solution. Once we filter the solution, then we will add magnesium powder to that filtrate. So since magnesium is more reactive than copper, it will substitute the copper from the copper sulfate and produce magnesium sulfate, and copper metal will be produced. Okay, then we will remove the residue of the copper, all right, by filtration. Once we filter and remove the residue of the copper, then our experiment will be finished. Crude oil is a mixture of hydrocarbons. Fractional distillation of crude oil and cracking of hydrocarbon fractions are two of the processes used in oil refinery. Which property of hydrocarbon is used to separate crude oil into fractions? We use their difference in boiling point to separate the fractions. So this is the correct answer. These are the main fractions obtained from crude oil. They are included from bitumen to refinery gases. Give one use for refinery gases. So refinery gases can be used for home cooking at home. We can also refer to the answer as camping gas or bottled gas. Give one use of kerosene. Kerosene is used as a fuel for airlines, so aeroplanes. State which fraction is the most viscous. Bitumen is the most viscous. Catalytic cracking is used to break down long chain alkanes into shorter chain alkanes and alkanes. Name the catalyst used in industrial cracking. In industrial cracking, we generally use alumina or silica. Their formulas are also accepted, so Al2O3 and SiO2. State the temperature used in industrial cracking. In industrial cracking, a general temperature between 600 to 700 degrees Celsius is used, so we will say 700 degrees Celsius because at a higher temperature we get shorter hydrocarbon chains. Tetradecane C14H30 can be cracked to make ethene and only one other hydrocarbon. Write a chemical equation for this reaction. So when tetradecane is cracked, it produces ethene plus a hydrocarbon. So we will write C14H30. It produces C2H4. Then we will calculate the remaining carbon, which is C12, and the remaining hydrogen, which is 26. Draw the displayed formula of ethene. Ethene is displayed with a carbon-carbon double bond with CH single bonds, 4 of them. Name the polymer formed from ethene. So ethene makes polyethylene. Explain why this polymer is difficult to dispose of. Polyethylene is very inert, meaning it is very unreactive, so does not decompose in the environment. A student investigates the reaction between zinc and dilute sulfuric acid. She uses this method. First of all, she puts 50 cm cube of dilute sulfuric acid in a polystyrene cup, measures the initial temperature of the acid. So a polystyrene cup is used so that the heat escape to surrounding is the minimum, because polystyrene cups are very good insulators. Then she adds 2 grams of zinc to the acid and stirs the mixture. Once she adds the 2 grams of zinc to the acid and then stirs the mixture, then the mixture gets hot, obviously. Measures the temperature of the mixture after 1 minute. So the reaction temperature she measures. The student does the experiment 3 times. For each experiment, she uses same size pieces of zinc but different concentration of sulfuric acid. So in the first experiment, 1 mole per dm cube, initial temperature, and we can see the final temperature, and the 1.52 mole per dm cube, they are here. Now we have to record this particular value. So experiment 1, initial temperature. Initial temperature, we can see this is 15. So initial temperature will be 16 degrees Celsius, and final temperature is 19 degrees Celsius. In experiment 2, the initial temperature is 16 again. Okay, that's great. So every experiment has initial temperature 16 and final temperature is 21. And on 2 mole per dm cube, the final temperature is 27.5. We can take up to 3 significant figures, so it's fine. So in every cases, it's 16. The last one is 27.5, and then the previous one was 21. So 27.5, 6 minus 16, so plus 4 will be 11.5. Explain why the temperature increase changes as the concentration of the sulfuric acid increases. So basically, as the concentration of the sulfuric acid increases, the reaction becomes more faster, it becomes more quicker, and the heat energy released within 1 minute becomes even larger, which is then transferred to the water more quickly, and the water's temperature increases faster. The student does another experiment at the same initial temperature as experiment 3. She uses the same size of pieces of zinc but uses 25 cm cube of dilute sulfuric acid. The acid is in excess in both reactions. Explain the effect, if any, of this change on the initial rate of reaction when compared to experiment 3. The initial rate of the reaction in this experiment stays the same. The main reason for this is the reaction is done at the same temperature, and even the metal that is used, the zinc pieces that are used, has the same surface area, and the acid that is used has the same concentration. Explain the effect, if any, of this change on the temperature increase when compared to experiment 3. The temperature increase in this experiment will be greater because in this experiment we have the same amount of heat energy is released. However, the amount of water, the volume of water is less. The volume of solution of the acid is less. So it will be much easier to heat it up to a very high temperature. Iron deficiency anemia occurs when the body does not have enough iron to ions. Iron deficiency can be overcome by taking iron tablets. A chemist wants to find out the percentages of iron 2 in one iron tablet. She uses this method. Weigh an iron tablet, dissolve the tablet in an excess of dilute sulfuric acid. Titration. Titrate the solution with potassium permanganate solution. The table shows her result. Mass of iron tablet 0.298 gram, concentration of potassium permanganate 0.02 mole per dm cube, volume of potassium permanganate solution added is 17.4 cm cube. Calculate the amount in moles of potassium permanganate in 17.4 cm cube of 0.02 mole per dm cube potassium permanganate solution. So number of moles will be 17.4 divided by 1000, because it is in cm cube, so we'll convert it into dm cube, then we will multiply it with 0.02. The answer will be 3.48 into 10 to the power of minus 4 mole. In the titration, 1 mole of potassium permanganate reacts with 5 mole of Fe2+. Calculate the amount in moles of Fe2+ in the iron tablet. Since 5 mole of Fe2+ reacts with 1 mole of potassium permanganate, so we will find out number of mole Fe2+. We will multiply 3.48 into 10 to the power of minus 4 into 5. So our answer will be 1.74 into 10 to the power of minus 3. Calculate the mass in grams of Fe2 plus in the iron tablet. So we will find out the mass of Fe2 plus by multiplying the number of moles with 56, and our answer should be 0.0974 gram. Calculate the percentage by mass of Fe2 plus in the iron tablet. So the original mass of this particular iron tablet is 0.298. So we will divide 0.0974 with 0.298 into 100%. This will give us 32.7. It's a good idea to write percentage by mass Fe2 plus and then do the math. A student uses this apparatus to demonstrate the electrolysis of molten zinc chloride. We can see there is a DC power supply, a lamp, positive and negative electrode, molten zinc chloride, and a heat source to keep the zinc chloride molten. The student records these observations. Crystals of shiny gray solid is formed at one electrode, so definitely that is zinc metal. A pale green substance forms at the other electrode, so definitely that's chlorine. Chlorine as in chlorine gas might be produced there. The lamp goes out after the teacher stops heating. So solid Zn chloride, zinc chloride does not have mobile ions to carry electrolysis. Now, state what is meant by the term electrolysis. The word electro means electricity and lysis means to break down. So the full form of this would be the decomposition of a compound or breakdown of a compound that is done using electricity. Guys, that will be 2 marks. The word using electricity has 1 mark. State why graphite is more suitable to use for the electrodes than magnesium in this electrolysis. Graphite will not react with chlorine, whereas magnesium will react with chlorine. So we need to have inert electrodes. Which of this is a correct statement for this electrolysis? The pale green substance is chloride. Now we know that the pale green substance is chlorine, not chloride ion. Both products are elements. Yes, zinc and chlorine is produced. Both of them are elements. So B should be the correct answer, guys. The pale green substance formed at the negative electron. You see, chloride is negatively charged, so must go towards the positive electron. So this is a wrong statement. The shiny gray solid is zinc chloride. No, that is only zinc metal. The student writes the ionic half equation for the reaction that forms the pale green substance. 2Cl minus plus 2 electron produces 2Cl. This ionic half equation has 2 mistakes. So what are the 2 mistakes? First of all, the chlorine must be diatomic and the 2 electron must be on the opposite side. So we will answer the electrons are on the wrong side of the equation. They should be on the right side of the equation. And we will say that chlorine produced should be diatomic Cl2. The lamp goes out after the teacher stops heating the zinc chloride because the electrons are no longer flowing through the wires. Explain why electrons are no longer flowing through the wires. The molten zinc chloride had free ions which were conducting electricity. Once the zinc chloride solidifies, then the ions are unable to move and there is no gain of electrons or loss of electrons at the electrode anymore. Guys, that's all for today's question paper. Thank you for watching for this long. Guys, best of luck for your exam and, continue watching the videos and solving more question paper. All right, guys, subscribe to the channel and write in the comments, if you have if there is any questions or if you generally want any question paper from the earlier years to be solved, let me know. All right, guys, see you in the next video, guys. Bye-bye.